Now we come to the second part of this chapter, calculating the time value of money. Firstly, you should know that the time value of money solves the basic problems of monetary value management, including determining the future value of a loan or savings at the present time, planning current savings for specific future financial goals. These are the two formulas that we will use in all the time value of money problems. We have already learned about this formula in the previous section, so I will not introduce it again. Exercise 1 has 3 questions. This is a basic problem that helps you become familiar with the time value of money formula. We will use the future value formula for this exercise. Accordingly, the future value at the end of the first year is 100 times the sum of 1 and 10% to the power of 1. Similar to the next question, the future value after 2 years is 100 times the sum of 1 and 10% to the power of 2. In question C, because the interest is compounded semi-annually, we need to reprocess the interest rate before applying the formula. The interest rate we get at each compounding time is 10% divided by 2, which is 5%. Therefore, the future value after 4 years is 100 times the sum of 1 and 5% to the power of 8. Exercise 2 is similar to exercise 1. The purpose is to familiarize you with the formula for calculating the time value of money. The number of days you have deposited your savings is 9 months multiplied by 30 days per month equals 270 days. Next, you calculate daily interest by dividing 10% by 360 days in a year. So, the amount you have after 9 months is $107.85. This is exercise number 3. We will calculate the time value of cash flow. To calculate the time value of cash flow, we will calculate the time value of each amount and then add them up. First, we will calculate the future value of the ordinary annuity at the end of year 3. For the first $100, we have 100 multiplied by the sum of 1 and 10% raised to the power of 2. Similarly, the next 2 payments have 1 and 0 compounding periods respectively. The future value of this cash flow is $331. For the annuity due, the number of compounding periods for the first $100 is 3. The number of compounding periods for the next 2 payments are 2 and 1 respectively. The future value of this cash flow is 364.1. So we can conclude that the future value of the annuity due is greater than the future value of the ordinary annuity. This is consistent with the theory of the time value of money. Exercise 4 is similar to exercise 3, but we calculate the present value of the cash flows instead of the future value. Here are the cash flows we will receive in the future, including 7 payments, a $100,000 payment today, and 6 payments of $50,000 received in equal amounts over the next 6 years. We use the present value formula to discount each payment back to today, and then add them up. The last $50,000 payment has 6 discount periods. The previous $50,000 payments had 5, 4, 3, 2, and 1 discount periods. Finally, we add the $100,000 we received today. And this is the present value of our reward, and it is clearly worth less than $400,000. Exercise 5 will help you understand more about simple interest and compound interest. First, you calculate the simple interest. It shows the interest you receive is only on the principal. Next, you calculate the compound interest by using the FV formula, and remember to subtract the principal $1,000. This is the total interest you receive on both the principal and interest of previous periods. So, to calculate the interest earned on interest, you just need to subtract the compound interest from the simple interest. The result is $31. This is the cash flow for exercise 6. You deposited $400,000 4 years ago at 10% interest and withdrew $100,000 at the beginning of each of the last 2 years. How much is in the account today? You can simply think of this as a cash flow with 1 inflow and 2 outflows, and then calculate the future value of this cash flow at the end of year 4. Although you are asked to calculate the present value, since the events are in the past, we will use the FV formula to calculate in this situation. And here is the result of this exercise. The content on the slide is just to explain more clearly how to do this exercise. Okay, we finish here. See you in next lessons.